Hello hackers, welcome back to Rust for Hacker series. Today we are going to learn some of new things in Rust in a bit different ways. What we are going to do is we are going to explore how to develop an application that communicates to our locally installed Ollama instances over the Ollama API. For this one to get worked, you should have Ollama installed in your machine. For that, you have to go to the Ollama site and you have to download the Ollama instance from here, and once if you install it, you can see it in your machine just by using this command. Either just give Ollama, it will give the options for you, and if you give Ollama list, this will list out all the instances that you have downloaded locally in your machine. And for cybersecurity related stuff, I recommend these LLM models like GPT, NeoX 8-bit, and Black Hat Hacker latest, and Dolphin Mr. latest. These are somewhat called uncensored LLM, so you can make use of this one for researching. You can ask questions. You can make it basically like your learning companion. And the one I'm going to show here is going to be DeepSeek R1. I did download the latest version, but it's only 4.7 gig, and I think it is 7 billion tokens one, so it is not like the 600 something that is the highest number of tokens for DeepSeek R1, but that needs a very powerful machine. I think for me, I don't have any dedicated GPU. I have only 40 gig RAM, and when I'm going to run this, is going to completely utilizing my for the DeepSeek R1, it's okay. Actually, I wanted to test it using this one, but unfortunately, when I'm using this one, it is taking too much of time to get the response. But for DeepSeek R1, it takes time, but sometimes like 4 to 5 minutes after utilizing my available RAM, it shows me the result. So in today's video, the application that I'm going to show you what it's going to do is it is going to communicate to the DeepSeek R1 model that I locally installed, and it gives a response from what we are asking for. And what I found is DeepSeek R1 is somewhat like kind of uncensored. It doesn't block you with any kind of information that the ChatGPT kind of models blocks and says is not safe. Again, this video is completely educational purpose. Its main purpose is learning Rust along with modern available technical stack like LLMs. So you have to download the Ollama instance. Once if you have that, you just confirm it using the commands that I showed here, and you can if you want to run it, if you want to run your model, you can use this command. This will download. If it's not locally available, it will pull the instance for you to your local machine and run it. So that's it for this one. For communicating this one to the using the API, what we need is what I'm going to use is a generate completion. We have a chat option and some other. These are the main two options that you can make use of. The chat option has more parameters, so we just start with the generate completion. It has these parameters: model, prompt, suffix, images, lot of stuff. But the thing that we are going to make use of is model and prompt. Then another one of the advanced parameters is called stream. Stream is basically if you set it true, you can see all the responses that is happening in the backend, and it will stream of everything to the screen. That may be annoying if it's it's showing everything what's happening behind the scene. So basically normal situations we set it up for false, but yeah, definitely you can make use of to true if you want to see what exactly going on behind the scene. So these are the things that we are going to make use of, and this is going to be the API that we are going to communicate to. Exactly what we are going to do is we are going to convert this to Rust, and we are making use of we are going to make use of Rust asynchronous programming capability to make it faster. And again, in real time, definitely the faster means you should be running it in a real good machine. Yeah, once you get that, you get a response back, and what I'm going to do is I'm just going to take the response only as a string. Basically it's going to be JSON on both sides. We are sending a JSON request and we are going to get JSON response back. So, and one more thing is, once if you have the Ollama installed, you can check your browser like this, and when you check your browser you should be getting a message like this. That means you have the Ollama server listening. So now I will show you the code that we did. The first thing is in here we need external libraries. It's called crates for the web communication and asynchronous programming. We need a request. Actually request, when if you check the documentation of request, if you come here, it shows how we should be adding this thing to your cargo.toml file. As if you have seen my previous videos, you know this is the area where you have to add your dependencies for your application. So when we are going to use making use of request, we have to add this dependency, because if you're going to use, suppose if you are not going to use asynchronous programming, you can completely avoid this one. We only need this, but here we are going to make use of asynchronous programming because this operation is going to be first of all, maybe in a slower machine it's going to be time consuming, so we have to make it as much as faster in a programming way to get the result. So basically we will be doing the same thing, but the syntax and other stuff will be different according to our need. So once if we and the other package that we need is serde. I think we have to pronounce it. I don't know how to pronounce this one. Basically I think it is a short form of serialization and deserialization, and for that we need this crate serde, and we have to add reference for that into your application, just like the request one. So what else we needed? And this is a way to add serde, and we are making use of one of the features in serde is called derive. This is needed because the way that the application is going to work in that way, because we are making use of this derive serialize on a struct and deserialize on another struct. This is basically for sending our request. We have three objects, three members in the struct: model, prompt and stream that I showed. I'll explain. This is actually defined here, don't get confused. This one we got it from the documentation here. So on this one we are just saying the stream is false, because we don't need to know, we don't want to be overwhelmed with the displays bars happening on that behind the scene when we are asking something. We just need the finalized output, so that's why we are going to set it up as false by using the stream. Then we create another object. Just see here, when you are using this hash derive attribute and using the in bracket, if you are saying serialize, this Ollama request structure object is going to convert into JSON, and this one is going to convert into JSON when it's at the time of deserialization. So what happens here is on the main function, and this is another thing, because we are going to use asynchronous programming using request, we have to make use of this one. This is called a runtime. Tokio is a runtime for Rust, and when we call asynchronous programming in Rust need a runtime. It doesn't have any default runtime, I think, and see, I don't know, I have to dig deeper into that, but most of the time everybody is recommending Tokio because it's one of the established and most downloaded runtime for asynchronous programming, and it is supported by some big companies, I mean the development, so somewhat is very stable. So that's why everybody is recommending to use this one. You just mentioned this Tokio main, that means we are telling the compiler that we are going to make use of Tokio runtime for asynchronous programming, and this is going to be an asynchronous application. So this async keyword make sure that it's going to be asynchronously called. And so another new thing you can see here is this one. This is nothing but when you say box, it's going to create a going to place this entire stuff into a heap, and this one I will explain later and in detail on another video, because it's called dynamic dispatching in Rust, because the compiler doesn't know what type of error is going to be at compile time. So because it's a common runtime, so any kind of error is going to be dynamically determined at runtime, it's not at compile time. That's called dynamic dispatching. I will explain with the examples on another Rust basic video. So what we are doing is we are collecting the arguments. The arguments are basically the model and the API server address. So once we supply that, here is another thing. For declaring static variables, I had to make these two static variables because it just needs to be initialized only once. For that, Rust is providing a mechanism called onelock. Onelock is nothing but it's a thread safe, what to say, compared to other programming languages. You can directly just mention the static variable and make it globally by declaring outside the main function. It's happening, same thing happening here, but it's more thread safe. So thread safe in the sense it puts lock properly on these variables when we are decorating it with onelock. So I have API URL as a onelock as a string and model name as same. Here actually we are not using any explicit threads other than the synchronous options provided by the Tokio. So it's very easy when setting it up is like the variable name, then dot set, and I'm just setting it up like this. Here this is a string, and see here I'm just because I'm taking the arguments into vector of strings, and I'm passing that the first argument means it's going to be the model name, that is to set up my model name. Means is I'm just initializing my static variable here, just think like that. And the same thing for API URL, that means this API server that we need to mention that the application is going to communicate to. And inside a loop, what I'm saying is you can ask the LLM and exit to exit, and here you can enter your prompt, and once the prompt is read into this one, you know how to read from the command, I mean like from the keyboard, because we did that on previous videos. So if you don't know, just refer the other videos. Once if you read that, if it's not exit, we just say, I mean this is just to say any kind of exit. It's going to be caps or small letter exit, it will break and the program will end here. So if it's not an exit and if it's a prompt, then we call this function. This is another asynchronous function, that's why we call an await for this one, and it is returning a result. So you can see it is returning the same result. If in a success case it's going to be a string, and in an error situation it's going to be error. It's going to be any type of error, so we are catching it using the dynamic error. So once we come here, since we know this is a static variable and we are taking back our value from that using the get method available, then I'm initializing my client from this package using the request. So once if I initialize the client, then I'm crafting my struct. This struct is going to be converted to JSON. So I'm just specifying my model prompt and mentioning my stream as false, and here I'm creating another variable that is taking value from my API URL, that is a global variable, static variable that we set from the command line. Then we send the request using the client post method, because when you come to here, I just showed that see this, we are converting this one. This is a post request, so we are doing the same thing here. We are posting to this URL that we mentioned. This is going to be our Ollama instance REST API. So then we convert our request to JSON. This request is nothing but this one, so we are converting this one to JSON. Then we send the request, then we await because we need to get the result back. Then we convert the response to JSON again, then again we wait for that to get it converted to JSON. So the question mark expands, as you know, I explained that in previous videos. Question mark expands the result type. So if the result type is okay, then it retains value, the actual value contained inside the result type. That means if the result type is like this, if it's an okay situation, you will get the value of the string. If it's an error situation, then it will return the error. So question mark will make it easier, expand that for us. So if everything goes fine, we get the response into this one, and we take actually you can see that the response that it's a struct that we declared, and it has only one member as a response that we declared. So once this response is deserialized to this object, we take the response and send it back to the main function. And you can see this is an asynchronous function and we are returning a result. That's why when we calling from the main function, we call this function with the prompt and we await and expand the result type. And if everything goes fine, we get the result type into this one, and if in case this is going to be an error, it's going to return, and this main function is handling the error here. So if everything goes fine, then it will ask for you the another new prompt, so you can enter your new prompt until you type exit. So this is the final, finally if everything goes fine after breaking it, it's a normal end for this, it returns and ends the main function. That's it, the simple thing, but the main thing behind this app was to learn the Rust more than because you can do this in any language, but just because we started a series on Rust, I tried it in Rust and it really works well. But the only problem I'm facing is my memory issue. So once everything is fine, you can build your application, and believe me, when you are building it the first time, your compilation time will be a bit longer than the one I'm going to show here. And one more thing, when you're going to use it in even if you're going to use it in your machine, try to make a release build, or not debug build. See, here is taking time because I will show my RAM. This is my memory usage. Yeah, it is somewhat okay. Let me see why it's too slow. It's not showing anything here. Yeah, this all good is running. Okay, see here, when you are running using cargo run, I showed this one also in the previous video. Like we have to, because we have an option we are checking here, like if the command line arguments are less than 3, we just prints this message to the screen. That's why you got this message. So the better thing is we can have show it from the shell. So from here, cd target and debug. Okay, let me expand this. Oh my, this image will be overriding. Okay, RustSeek. And what instance I'm going to run is I'm going to run Ollama, run deepseek one. Run it. Then I come here, I'm going to say my model is deepseek one and my API is it was there on the documentation for Ollama. This is going to be the API that we are going to communicate. As I said, there is another option called chat. You can try that, but that need more parameters than this one. So here I'm going to give this generate. So just confirming that this is running here, and going to see this is a message. You can ask anything for LLM. For the learning purpose, I have added some prompts that you can try with this one. This will be available in my GitHub for learning purpose, and again I'm saying it's an educational purpose video. So, and I'm just going to post this here because I'm not sure how long. The last time when I tested, it did take nearly 4 minutes to finish it off. Maybe it's going to take the same here. Let me check my RAM usage. Yeah, it's not bad, but my CPU usage is getting higher. It's now reached 80%. As I said, I don't have any explicit GPU available, and the only thing I have is 40 gig RAM. So maybe it won't get stuck. Yesterday when I tried with this the Black Hat hacker instance, and completely got stuck. But DeepSeek is really better than that. Even though the other models I mentioned, even this one, it did take a long time to get a response from this model. So after testing these two, even the Dolphin Mistral is good, but the response is giving is not that great compared to DeepSeek R1. Even with the smallest model for DeepSeek R1, it is really generating good result, but again it's not as good as the highest model. So, and again our aim is basically learning Rust. So I'm going to post this video here. Maybe it's going to take some more time, so I'll come back to and show you how it works. And basically what we learned here today is how to declare static variables, how to make use of asynchronous programming, and adding external references to your Rust app. Because I'm going to continue the series with some more basic stuff. We'll be going back to the basics. 1 or 2 projects I planned. and the other thing is going to be after the basic 2 more projects. We will be moving to the web security part, or automating web security testing. Then again we go to some more advanced one to the networking side. That's why I planned, so stay tuned for more to come. I'm just pausing this video here, and I will be back once the result is displayed here. Yeah, we got the result back after 5 minutes, and this is the result it's showing. See, DeepSeek is returning. I mean, it shows you everything. Like this is the only thing. I mean, this makes the DeepSeek different. It shows the thinking process, then it shows you the steps, like what you had to do, because we asked for this thing. Like, imagine you are a hacker tasked with breaching a fictional company's network, then what should be your approach, tools and other techniques. So you got it like this. You have to verify this result, and you just use your common sense. Is this going to be good or not? So you can ask anything basically. From my experience, I didn't get any censorship on DeepSeek R1. So regarding, come back to our tool. So our tool is asking for the next prompt. Either you can give next prompt here, or you can exit. Now I am exiting because I don't want to waste my memory. So it's a safe exit from the app. So I'm coming here, I'm saying a bye from here. I'm going to stop my DeepSeek, otherwise it's going to create more memory issues for my machine, because I don't have any dedicated GPUs, as I said. So, and one more thing, this app is not just for hackers. You can make use of this app to any Ollama instances that in your machine. It doesn't mean to be just only hacking stuff, but if you are learning pen testing or cybersecurity related stuff, these are the recommended models that I personally experienced. The GPT Neo X 8-bit, and of course DeepSeek R1, then the Black Hat and Dolphin Mistral. I haven't tested Llama 3.2 for cybersecurity related stuff. I don't know whether it has any censorship or not. If you have done that, please comment and let others know what you have done with that. And with this project, I will be uploading the prompts, so you can try and edit these prompts and you can learn. Again, I'm saying it's completely for educational purpose. Our main aim is to learn Rust here, and developing and utilizing Rust asynchronous capacity or capability to develop application that communicates over the REST API. That was a thing that we learned here, and most of this basic stuff we learned in previous videos. So if you missed the other ones, please go and watch that first, then come back here. I'll be deploying this code to the Rust hacking series. What I'm thinking, I will make this as a separate project, because this is completely different from the other learning stuff that we are continuing, but I'm just adding this to that series in my video. So if you feel interested in Rust, and if you are interested really in programming, I know programming is not for everyone, so only if you are interested in programming, and if you are interested in security, and if you are interested in learning Rust, you can continue watching the other series, or the previous ones, and something that's going to come. So I'm stopping this video here and say bye from Alphas now. We'll be seeing soon with other security tool projects in Rust very soon.